So things like mindfulness training, things like body scan. So they've been shown to improve functioning of the insula. So there's increase in gray matter. They've been shown to improve interoceptive kind of your confidence and your sort of ability to engage in those processes. So what I would predict is that if you do mindfulness, and that's actually a trial that we're about to start in coming months, that if you do kind of mindfulness training for a long time, that might actually improve your imagery because it improves your interoceptive system.
Hello, everyone, and thanks for joining us again today. Dr. Juha Silvanto is speaking with us about aphantasia and the autonomic nervous system. Dr. Silvanto comes from a bit of a different background than some of the other speakers we've had, and his research on aphantasia is really unique and exciting. So, Dr. Silvanto, thanks for joining us today.
Thank you. A great pleasure to be here and to present my data, which was actually collected from the Aphantasia network. So I'm also very keen to hear, kind of get feedback from you on what your thoughts are. Bit of a background of myself. So I'm a cognitive neuroscientist. I've been working on the visual system for a very long time. I've been working on aphantasia since for about 10 years now. Recently, I've become interested in investigating the interaction between the autonomic nervous system and mental imagery. The autonomic nervous system plays a very important role in high-level cognition. And this is something that has become quite a sort of hot area of research in the recent years. And it appears that it also plays a very important role in mental imagery. So I will start sharing my slides. Yeah. So I want to start off by talking a little bit about the nature of imagery, because that's really at the heart of our interoceptive model of aphantasia. We use mental imagery to think about events that happened in the past, and to plan for the future. And very often these events involve obviously autobiographical memories, things that were important that happened to us, such as, birthdays and weddings, spending time with the family, sometimes sad events. But in any case, they tend to be emotional events. And also they tend to be events where kind of we re-enter the physiological state that we experienced at the time of the original event. And that's really at the heart of mental imagery. That is a multimodal experience, and it is an experience where the sensory components are deeply intertwined with our emotions and our physiological states. And I think that's important because very often when cognitive neuroscientists study imagery in the lab, we kind of break down the mental imagery experience into smaller components. And we try to use stimuli that are very low level, such as gratings, which are, of course, easily controllable. But what happens, I think, is that you kind of lose the fundamental nature of imagery. You kind of throw away the baby with the bathwater because you take away the actual, what's really fundamental experience of imagery. And I think that's theoretically important because consequently, the way imagery is often conceptualized in the literature is in terms of sensory dimension. So from a sort of neuroscientific perspective, imagery is often thought to arise from activity of the same areas of the brain that are responsible for visual perception, such as the occipital cortex. So it's kind of seen as a sort of internal parallel of visual perception. Whereas what we are arguing is that, in fact, we should think about imagery in a more sort of holistic way and as an integration of those sensory representations with our emotions and with signals from our body. And the key component here is interoception, which basically refers to our ability to sense signals from inside our body. So things like heartbeat, your breathing, whether you're hungry, whether you feel tense. Interoception is really the link between our body and our conscious experience. So it is a very, very important component of our functioning. And, we use it for more low-level things, such as, our body tells us when we're hungry, we know when we need to eat or when we need to drink, we need to sleep. But also, it's important for emotions. So, for example, when we feel nervous, we might feel butterflies in our tummy. We're excited, our heart is racing. So those physiological signals are the foundations of our emotions. And emotions arise from us labeling those physiological responses with sort of more abstract concepts. So when we start feeling nervous, we start feeling those butterflies, we realize, yes, now we are anxious. Interoception is very important for us to regulate our body, our breathing, our heart rate, and so on. And is basically a very fundamental part of our sense of self. This phrase of to feel is to know. When we stop sensing our body, we lose access to parts of ourselves. And the main source of these interoceptive signals is the autonomic nervous system. Now, the autonomic nervous system, it regulates sort of key bodily functions like the heart rate, breathing, digestion. It basically constantly generating bodily signals, which the brain is then monitoring. And as I mentioned in the previous slide, these are very important for our emotions, our stress responses, our sense of self. And there are two branches of the autonomic nervous system. So the sympathetic branch, which is also known as sort of fight and flight system, this is activated during stress. So it produces highly salient signals, such as your heart begins to pound, that you get breathless, that you feel during anxiety or when you're alert. And then you have the parasympathetic branch, which activates during calmness. So it slows your heart rate down, supports digestion and recovery, and so on. Now, autonomic nervous system also plays a very important link in our mental health. And this is something that's been increasingly realized in the literature. The fact that how we kind of understand our body is really kind of the foundation of mental well-being. And the reason why the link arises is that if you experience chronic stress, if you experience a traumatic event, that can sensitize the autonomic nervous system. So you basically enter this constant state of arousal, you constantly, racing heart, breathlessness, and so on. And even when you're in a safe environment, there's no reason to feel so, your body is still giving those signals. And the main problem that arises from this is that there's this confusion between your internal signals and your brain's internal model of the body. So what your brain is expecting. If you're in a safe environment, the brain is not expecting those signals of sort of being alert, being stressed. And when you actually experience those signals, this gives rise to mental health systems. So you start feeling anxious, you start feeling emotional confusion because you don't understand what your body is telling you. And consequently, one consequence is detaching yourself from your bodily signals, which is something I'll come to later when I talk about acquired aphantasia. Now, the way this all links to imagery and aphantasia is that, as I mentioned before, mental imagery really requires the integration of emotional and physiological components with sensory modalities. So, for example, when we imagine a familiar person, yes, we will first bring up the visual features of the person, but that comes together with the kind of emotional attachment to that person and the bodily states, the physiological states that we associate with previous interactions with that person. And the physiological foundation for that's been shown by people like Sokolov, is that when we encounter a stimulus and we encode a novel stimulus into memory, the physiological responses that the stimulus evoked get also encoded into memory. And during recall, or when we create a mental image, we kind of re-enter that physiological state that we had at that time. So part of the process of recalling events from autobiographical memory, from episodic memory, is to not just to retrieve the sensory features, but also the emotional states and the physiological states that we are associated with that memory. And what we suggest is that kind of the inability to engage the autonomic system prevents mental imagery from being created. Now, the other reason why interoceptive signals are very important is that they play a key role in what's called sense of agency. So that's the idea that we are in charge of our actions. So for example, when I decide to move my hand, brain makes a prediction of the outcome of that movement. And when I move my hand, then I get feedback from that movement from my body back to my brain. And the brain is trying to figure out if there's a match between what it predicted would happen and what is actually the feedback from the body. And so imagine if somebody kind of bumps into me and moves my hand by accident. My brain didn't make a prediction of the happening. I still get the feedback from the body. And obviously there's a mismatch between the two. So that tells me that I did not generate this action. It was generated by an external agent. So in that way, the feedback from our body is very important for us to understand whether we initiated a certain action. Now, this kind of feedback is also important for mental events, because even when we don't explicitly move our body, but when we engage in cognition, such as mental imagery, this also triggers shifts in our body, such as the heart rate and the breathing. And we use those signals to confirm that we are in charge of this mental event. Now, what we are arguing is that in aphantasia, because the interoceptive system is suboptimal, this matching process cannot happen. So what happens is that when we initiate a mental image, we are unable to get feedback from the interoceptive system. So the brain concludes that basically I did not initiate this event, and then it becomes suppressed. So the feedback from the interoceptive system is important to kind of the activity that is induced by triggering the mental event. And this allows for the mental image to become conscious. So I'll now move on to talk about some of the empirical work that we've done. So this is brand new data that we collected with the help of the Aphantasia network, where we examined whether aphantasia is indeed associated with changes in autonomic reactivity. We used two well-known questionnaires for this. The first one is the body perception questionnaire, which assesses basically how individuals experience, how strongly and frequently they experience autonomic symptoms. These are divided into two parts. So there's the supradiaphragmatic symptoms, which basically refer to symptoms arising from above the diaphragm, and then those below it. So there are questions such as, my heart often beats irregularly, I have shortness of breath. All of these are sort of key aspects, key symptoms of the autonomic reactivity. The other one that we used is called the atrial fibrillation scale. This is a scale that was developed to look at cardiovascular conditions such as arrhythmia. The reason why it's also being used beyond that domain in cognition is that a lot of the symptoms of anxiety and sort of somatic symptoms, they actually are very similar to symptoms of heart conditions such as palpitations and breathlessness, and that's why a questionnaire on autonomic arousal like this is being widely used. In the end, we had a sample of 307 aphantasics. We divided them into different groups on the basis of the PSIQ score. So we had individuals who reported a complete lack of imagery, so who gave a rating of 1 on all the scales on this, and then individuals who had a bit of a higher rating, but still below the sort of cutoff rating of 4. This cutoff rating is based on the work of Reshan Reader, who's published on this. And then we have typical images as a control group. And these are our results. So here on the x-axis, we have the three groups. So we have the control group, the individuals with what we call core aphantasia, and then individual with hyperaphantasia. On the y-axis, we have the symptom score. What it means is that the higher the score, the more stronger you feel, the higher is your self-reported autonomic reactivity. And what we find is that if we compare the control group with the aphantasia group, what we find is the aphantasia group has a significantly lower level of autonomic reactivity. So they basically they report less frequent and less stronger symptoms of the autonomic nervous system. These are particularly significant in terms of the supradiaphragmatic symptoms. So these are basically things like heart rate and breathing. These are symptoms that respond very rapidly to emotional states. So these are directly regulated by the sympathetic nervous system. They're closely linked to brain areas that connect to emotions like the amygdala and the insula. And it is these symptoms that appear to be less active in congenital aphantasia. This is the AFF's questionnaire. Here again, so this is the questionnaire that looks at sort of cardiovascular arousal symptoms. And here again, what we find is that particularly when we look at the heart symptoms, so again, here is the total score on the y-axis, what we find is that individuals with congenital aphantasia have significantly lower levels of heart symptoms compared to controls. So again, what this suggests is lower level of autonomic reactivity. So basically what this suggests, and the way we interpret this, is that congenital aphantasia is a associated with decreased autonomic reactivity. So there's hyperarousal. And the consequently happens is that the consequence of this is that there's a weaker link between bodily states and mental representations. And this leads to issues in terms of binding sensory information with physiological states, which we argue is important for mental imagery to arise. So basically, in this view, aphantasia reflects a failure to embody or emotionally ground the imagined content in your body. Now, I'm going to talk a little bit about acquired aphantasia, which is something that is less common than congenital aphantasia, but it's a very interesting phenomenon, and it also kind of opens a window to assess the fundamental mechanisms of how imagery might be lost. The interesting thing about the literature these days is that most currently is focused on kind of neurological aspects. Lots of papers looking for neural correlates of acquired aphantasia, and there are indeed reports of aphantasia arising as a result of a brain lesion. But actually, even in the 19th century, there were many reports of aphantasia arising as a result of psychological factors, mood and affective disorders, such as anxiety, depression, depersonalization. And what this suggests is that there is an affective pathway to aphantasia, where you have mood disturbances, which leads to kind of detachment from yourself, including ability to engage in mental imagery. So to examine these sort of causes of acquired aphantasia, we did a study where we asked individuals who self-report acquired aphantasia to kind of report the experience of how they think the aphantasia came about. And we also gave them the same questionnaires on autonomic reactivity. These are the self-reported origins of acquired aphantasia. So participants were given different conditions that they could choose from. They could choose more than one condition. So for this reason, if you look at the table on the left, we look at the categories of how individuals reported how they felt as the origin of the aphantasia. Very often they report a combination of factors, combination of neurological, psychological, and pharmacological factors. About 40% of our sample reported only psychological factors. And these includes conditions such as depression, anxiety, PTSD. In total, 61% of our sample reported a psychological origin. In contrast, about 40% reported a neurological or medical origin. This could be a brain injury, this could be a cardiovascular event, a virus, and so on. 30% of the participants reported a pharmacological reason. The vast majority of these individuals also had psychological diagnosis. So it's a little bit difficult to disentangle the underlying psychological condition from the effects of medication. But the point is that there appears to be a very strong psychological component to acquired aphantasia. Now, in terms of the autonomic reactivity, so these are the results from the BBQ scale and the AV scale. So what we have here on the x-axis is the acquired aphantasia group. Here on the right, the control group. On the y-axis, again, we see the total symptom score. And what we actually see is the opposite pattern compared to congenital aphantasia. So in this case, we actually observe a increased reactivity. We see this in both the BBQ score and also the AFS score, which is the sort of cardiovascular scale. So we basically find that in acquired aphantasia, there's a heightened autonomic reactivity, which is the opposite pattern that we observed in congenital aphantasia. And this is the sort of model that we propose for acquired aphantasia. So basically, what we suggest is that you can have a psychological event or neurological event, which leads to change in the functioning of your autonomic system. So basically, you have a failure of autonomic regulation, that this leads to overreactivity to minor stimuli, sort of in constant state of arousal. So you have heightened awareness and intensity of internal bodily signal, and consequently, because those signals are so sort of overpowering, you disengage from them. And because you disengage from those bodily signals, you're no longer able to create mental images. An interesting thing here is that it's been known, there's a lot of literature on the developmental risk factors of autonomic dysregulation. It is known that neurodevelopmental traits such as ADHD and autism have consequences on the autonomic nervous system. It is also known that early emotional adversity, such as childhood trauma, leads to autonomic dysregulation. So to understand how these factors kind of interact in congenital and in acquired aphantasia, we also assessed these components. This is our data from the childhood trauma questionnaire. Again, here on the x-axis, we have the acquired aphantasia group, here the control group. On the y-axis, we have the childhood trauma score. So this is a total score. Here we see that the score is significantly higher for the acquired group compared to controls. And this is particularly reflected in the sort of the emotional scales, emotional abuse and emotional neglect of the childhood trauma questionnaire. We see a similar pattern of results in the neurodevelopmental condition. I mean, this is something that has been reported before many times in the field, that there's a high level of autism traits in aphantasia, as well as ADHD traits. And we also find higher level of anxiety, which is the GAD score. So all of these factors appear to be higher in acquired aphantasia. So coming back to this model, so what we see is that what we would argue is that there are developmental risk factors which make you more likely to experience sort of autonomic symptoms, autonomic dysregulation. And what might be happening is that this is a sort of predisposing factor. And then if you have a traumatic event or a mental health condition later in life, you're more likely to have a stronger effect on your autonomic nervous system. And for this reason, you're more likely to develop more stronger consequences of it, such as full disengagement from bodily signals, which then leads to aphantasia. So I want to summarize the sort of similarities and differences between the interoceptive profile of acquired aphantasia and congenital aphantasia. Really the key difference, while in both cases there's a loss of imagery, the autonomic nervous system profile is quite different. So in the acquired cases, the ANS is hyperreactive, so we have increased arousal. In the congenital cases, it's hyperreactive, so we have reduced autonomic signal. In terms of the interoceptive profile, so our experience of our body signals, the acquired cases, individuals find them overwhelming, whereas in the congenital cases, they are weaker. So there's low physiological feedback from your body. And in both cases, this leads to aphantasia, but for different reasons. So in the acquired cases, you kind of distance yourself from your bodily feedback. It's sort of a protective mechanism. And consequently, then you lose your ability to generate mental images. In the congenital cases, it's different in the sense that imagery is underdeveloped. It doesn't actually arise because of the kind of muted body-mind interaction. I have some few more studies left to talk about. I just very briefly mentioned this link between interoception and autobiographical memory. And this is important because obviously autobiographical memory is one of the key kind of deficits that we observe in aphantasia. So it's important to examine whether interoceptive issues are related to these aspects. What we did was we used two well-known questionnaires in the field. So one is called the MAIA, the Multidimensional Assessment of Interoceptive Awareness. So these differ slightly from the autonomic reactivity questionnaires that I mentioned before, in the sense that these are a bit more high level. These are more about how you react, how you sort of emotionally engage with your body. So the questions are such like, I notice when I'm uncomfortable in my body. I try to ignore pain. When I feel physical pain, I become upset. So they're more about how you respond to signals from your body, rather than simply your ability to detect those signals. The other scale that we used is the one developed by Jennifer Murphy, interoceptive attention scale, which is about how much you pay attention to signals from your body. So how much attention you pay on whether you're hungry, whether your heart is beating, and so on. And what we find is that, first of all, if you look at episodic memory, here we replicate the well-known effect of a major impairment. But what we also find is that in most of these scales of interoceptive awareness, aphantasic score lower than controls. Particularly when it comes to like emotional awareness and noticing, we find significant differences between the groups. So again, these are congenital aphantasics, and we replicate the pattern of kind of lower engagement with signals from your body. And we also did some mediation analysis where we look at how, what is the link between the interoceptive awareness and the autobiographical memory. And what we basically find is that your imagery ratings mediate the link between your interoception and the autobiographical memory. So what this suggests is that if you're attuned to internal bodily sensations, this enhances your capacity for imagery, which in turn increases your ability to recall personal memories. I'm going to skip the last study just because I think we're running out of time, but just to want to bring it all together. So what we're arguing is that we should move beyond kind of sensory explanations of aphantasia and think about it more globally as a sort of reflecting differences in how the brain processes bodily signals and how the body kind of is unable to combine those internal signals with sensory information. The autonomic nervous system plays a key role here. The pattern of the result is opposite for congenital versus acquired aphantasics. So in congenital aphantasia, the signals from the ANS seem to be blunted, whereas in the acquired cases, they're heightened. But in both cases, the interoceptive process is disrupted. And what we argue is that this is the reason why imagery cannot arise in these individuals. What we are currently trying to do is to examine whether increasing your interoceptive abilities has an effect on your mental imagery. So things like mindfulness or biofeedback, they've been known to improve your interoceptive abilities. So the key question is, will that have consequences also on your ability to engage in mental imagery? And just finally, I would like to acknowledge my colleagues. So a lot of this work has been done with Dr. Yoko Nagai, who is at Brighton and Sussex Medical School. She's an expert on interoception. She's a great colleague. And also working with Timo Kwame, Melly Monsell at Bonn, and Venyu Gao, who is my PhD student. Thank you very much.
Dr. Silvanto, thank you so much for that. That was really quite interesting. For anyone who's watching along, feel free to ask your questions in the comment section and we'll get to them. I have quite a few questions, but my first one, I guess, is kind of the chicken and egg problem. How do we know that the lack of interoceptive awareness is driving the lack of mental imagery as opposed to the other way around? Could it be the lack of mental imagery is reducing the ability to have interoceptive?
Yeah, I mean, there are two ways I would answer that question. So one, people often say that imagery is important. So, we know this link between mental imagery and emotions. That's well known. And people often say that the link arises because mental imagery is needed for us to kind of model social interactions. It helps to understand them. But what I would argue is that if you think about how neurodevelopment, what comes first? The first thing that really comes is the interoception. Signals from your body. As a young child, you learn when you're hungry, when you need to go to the toilet. That's really the foundation. Then come your sort of emotions, and mental imagery develops much later. So I would argue that sort of order of events kind of suggests that interoception is the foundation. The other thing I would argue is that if we look at kind of the comorbidities of aphantasia with other condition, we find there's comorbidity with alexithymia, which is the inability to kind of understand your emotions. That's an interoceptive condition. Obviously, the comorbidity, I know it's a little bit controversial, comorbidity with autism, ADHD, these are interoceptive conditions. So all this suggests that imagery is a symptom alongside with things like alexithymia and autism, ADHD, and the major theme is interoceptive issues. I think that's the kind of the reason why the foundation is interoception, because we get a range of different effects, the different conditions that kind of go together with aphantasia.
I'll be traced back. Why do you think it seems the congenital and the aphantasia and the acquired cases have the opposite cause for or effect on the interoceptive differences? Why do you think that might be?
Yeah, I mean, I think, if you think about the acquired cases, so this is something that, the studies in the 19th century already reported. The fact that if you have a very sort of traumatic event, if you have a mental health condition, that leads you to dissociate from yourself. Something called depersonalization. You get distance yourself from your, and part of the way you do that is you kind of suppress sort of your ability to access your autobiographical memories as well. If you had a traumatic event, you don't want to go back to those events. You kind of suppress your ability to do that. And the key to suppressing, kind of depersonalizing, is via the interoceptive system. Because the step number one, you distance yourself from your bodily signals. That allows you to distance from overwhelming emotions. That's the reason why, if you have a certain mental health condition, if you have a traumatic event, you get that dissociation. And what we're arguing is that part of that dissociation, one consequence is aphantasia. But it is the outcome of that process of you pulling away from yourself, from your feelings, from your emotions, which comes from interoception.
We have an interesting question here from Barbara, which is, I'm a complete aphant, but I do have visual dreams. How does that fit into your theory of muted interoception?
Yeah. So basically, what we argued in one of the papers that I'm sharing is that key aspect of one key interoceptive function is the sense of agency, that we are in charge of our actions. And obviously that is a key difference between dreaming and voluntary mental imagery. I think about 50% of individuals with aphantasia can experience visual dreams. And so it does appear that aphantasia is particularly related to the voluntary aspect. And this is something I talk about in one of the papers I shared. Of course, when it comes to the voluntary component, our interoceptive system plays a key role in kind of giving rise to the sense of agency. So the feedback from our body is what allows us to tell us that we are in charge of our actions, that we initiate our actions. If we don't get that feedback from our body, there's a mismatch between what the brain is predicting and what our body is telling us. And the outcome is the brain concludes, okay, that was not my idea. We didn't initiate that. And I think that's one of the key mechanisms here. That because you don't get these robust interoceptive signals, this process of matching your brain's predictions and signals from the body is failing. And that's why, that's a very good question. I think that gets to the heart of aphantasia, the voluntary aspect. Because yes, many individuals do have dreams, but it is the ability to actually to create those images that's impaired. And the interesting thing about as well is that when we sleep, our interoceptive system is shut down. So the dreams are basically cortical in nature. We don't get that feedback from our body. In dreams, we don't have those interoceptive experiences. So the nature of dreams and mental imagery is also different from that perspective. But yes, that's a very, very important point around the voluntary front.
Yeah. And mental imagery can also be a multisensory experience. And we see that there are differences among aphants where some have it globally. They can't access any of the mental imagery senses. Some might not have visual, but still be able to imagine sounds or, someone's voice, a cup of coffee. Do you think that the similar phenomenon with the link between the interoceptive system is selecting for some of these different mental imagery senses?
Yeah. I mean, that's one of the open questions in the field. I think that's a really good question. I think that's something that we need to look into further. I think it's one of those things that the field hasn't answered. I think the more you rely on, the visual imagery is more probably effective because it's more reliant on that emotional interoceptive side of things. So if we think about visual imagery, it is often around, episodic memory of important events, and that's more intertwined with emotions, with bodily states. So I think that's probably a reason why a visual domain would be more strongly affected. But that's something that we need to look at in the future. I mean, that's definitely one of the open questions in aphantasia research. I think, so obviously we would expect a higher prevalence of what we call interoceptive conditions, which are things like alexithymia, autism, ADHD. We would expect various mental health conditions have interoceptive component. Even things like, so the other thing that is important, that the interoceptive system and the brain area that is at the heart of it, at the insula. The insula plays a very important role in integrating information between senses. So what I would predict is that there would be a higher sort of worse performance in tasks that involve binding between modalities. So if it's indeed the case that it is, insula, which is the brain area that we think is involved, which is the key region for interoception, it is sort of a hub that connects, different brain areas and different sensory systems together. If indeed that is the sort of underlying problem in aphantasia, then we would expect kind of binding between senses to be affected. And that could involve, beyond the imagery domain, even often in sensory perception, we need to bind auditory and visual information together. So I would predict there might be sort of issues there.
Interesting. One of the interesting things that you said, though, is that you can potentially improve the interoceptive awareness. Can you talk to me a little bit about that, about what techniques maybe work for this, and for some of the events at home who might want to try and see if they have any success?
Yeah, so something that has been done, so things like mindfulness training, things like body scan, so they've been shown to improve functioning of the insula. So there's increasing gray matter. They've been shown to improve interoceptive kind of your confidence and your sort of ability to engage in those processes. So what I would predict is that if you do mindfulness, and that's actually a trial that we are about to start in coming months, that if you do kind of mindfulness training for a long time, that might actually improve your imagery because it improves your interoceptive system. So that's kind of like a test of the model of if a byproduct of improving you're improving the link between your mind and your body. So that's why things like mindfulness, meditation are important, because they kind of they help to connect your mind and your body. And that's the key, I think, here.
Barbara asks, is congenital aphantasia developed in the womb or through very early post-birth trauma and experiences? Do you have thoughts maybe or hypothesis on that?
Yeah, that's that is a very good question, a very complex one. We know that a lot of the conditions that go together with aphantasia have that origin during gestation. We know that ADHD, we're looking at even things like hypermobility. That's one of those things that are you think is completely different from mental imagery, where you have bendiness, where basically your joints are very bendy, which you will think is so different from high-level cognition. But a lot of these things that don't seem to go together appear to go together. They do have, there are theories that they do have origins in the womb. But obviously, something that people have raised is that, maybe very early on in life, if you have a traumatic experience, you forget that you ever had imagery, perhaps. So maybe you're not congenital, maybe you're acquired. But what I would argue is that, because interoception develops so early in life, it's when you're born, you start using interoceptive signals. So, it's likely to be something that you're born with. And it's something that is either genetic or something happens during gestation. But it's one of those things that is highly, it's very much debated in the literature on autism, ADHD. It's very difficult to tease apart. There's probably all these different factors play a role. But that's definitely a key question that we need to answer to really understand the nature of and the origins of congenital aphantasia.
Well, Kathy has a relevant comment here. She says, I now have no visual dreams, but I think I maybe had them as a child since I remember one reoccurring. If the trauma was at a very young age, have once had visual memories, just don't remember them. So I think that goes basically to the point we were just making.
You probably would remember you've had imagery and you lost it. So that's one thing I think that makes it less likely that to be the case. I do think the congenital cases are truly congenital, and and also because the comorbidities that we observe with other things, and some of these things are very kind of physiological. So that sort of makes me sort of lean towards an explanation of genetics and something in gestation, something in the womb.
David here says, you suggest a possible link between aphantasia and autism. Nevertheless, I thought other recent research, he's talking about Dr. Arnold. We had Dr. Arnold on last month,
Okay.
who's basically was challenging the findings.
Yes.
So what are your thoughts maybe on some of the research that's been done?
Yeah, we did find a very significant effect on that. And I think that what it often boils down to is that some of the questions in the autism questionnaire are around mental imagery. So I think the argument is that the whole debate becomes a bit circular because you're basically asking the same thing. So it's not a surprise they correlate. So I think that's still something that needs further study. I think needs to be resolved, maybe in larger samples. I would argue that it does fit into the picture, the whole profile, the interoceptive profile that we're proposing. Autism has a very strong interoceptive component. In autism, generally, the individuals say that they are very good in interoception, but actually the objective performance is quite poor. And we also know that they have issues, so they have impaired in tasks that assess agency, which is something that is, what we propose plays a key role in aphantasia as well, being a condition of lack of voluntary mental imagery. But I think it's one of those cases where we just don't know yet. I think a lot of studies suggest a link. There might be issues about some overlap between the way they are assessed. So I think theoretically, the link makes sense, but I don't want to be too strong about it because I do think more research is needed.
Makes sense. And if the model really is about interoceptive, the link between interoception and autism is also a cause of that, then there's a good case to be made. There's another question here: is interoception related to intuition?
Yeah, if by intuition you mean gut feeling, it definitely is. Gut feeling is a very good example of how bodily signals affect high-level cognition. When we need to make a decision, we often get a gut feeling of what we think we should do. We can't really consciously verbalize it, but we just feel that this is what we need to do. And if that's what you feel by intuition, yes, definitely. And that's one of those things why the link between the mind and body, again, is so important, because really the better kind of insight we have to our bodily signals, the better decisions we make, the happier we are. It's just something that I think the Western medicine hasn't realized until quite recently how important those links are. But yeah, things like intuition, definitely, signals from the body play a very important role.
Yeah, interesting. I'd be interested in maybe some of the listeners' thoughts on their own personal experience with intuition, and if they feel, they do get those gut feelings, because then the theory would be then, those gut feelings aren't experienced maybe as often or as strongly.
Yeah.
We have one more question here from Adam, who says, along those lines around mindfulness, I wonder is it endophasia increases interoception? I personally feel like my interoception is very high and also have an endophasia. No inner monologue or inner voice. So there's been some recent research showing that some people don't have inner speech.
Okay. So the question was around, if just remind me the question again, the question was if interoception is related.
Yeah, basically the link, I guess, between interoception and inner speech.
Yeah. That's speech is an interesting one. That's something we want to look at in the future. So I don't have really any specific kind of specific results or any specific sort of ideas around that. That's probably something I need to think about a little bit more.
Yeah. Because it's one of those other areas where there's another, kind of domain of cognition, of some kind of different conscious experience that people are having. Some aphantasics say they do have, very strong inner speech. I would kind of resonate myself with that. Some others say that they don't at all. But it could be related or something totally different.
Yeah.
Just based on my last thing there, I do have. So I'm I'm aphantasic and intuitive, I would like to think, at least. So there are some
Yeah.
different thoughts. I get gut feelings in a verbal sense, which is the main way I have mental imagery. So imagery is in quotes there. So I guess that gut feeling being
Interesting.
translated into inner speech, as we were just talking.
Yeah. It's interesting. Yeah.
Well, overall, very interesting finding, and it's I think a new, unique kind of perspective on mental imagery and on aphantasia, and I think it's important work, and I really thank you for coming to share with us today.
Thank you. And I would like to say, any of the listeners have any thoughts or any suggestions, any comments, feel free to email me. I'm always happy to engage in interactions.
Great to hear. And I do know Jason, our producer here, has linked the papers in the chat. We'll also put them in the Discord channel for any of the members to see the papers if they want to read more. And I think with the papers have your contact information if they'd like to discuss it personally. Thank you so much, everybody, and look forward to seeing you again at the next one.
Okay. Thank you.